Hello students and welcome back to the Statistics and Mathematics Teachers course on Stochastic Processes. So in today's video, we're going to just solve questions on the Piosson process, thereby wrapping up everything we've learned about the Piosson process. Okay, so our first question, let's just look at it. The A. You are given that n of t follows a Poisson process with rate lambda is equal to 2. So calculate the conditional probability that n of 2 is equal to 3, given that n of 5 is equal to 7. Alright, so let's look at this in terms of arrival. So I try to say that at time 5 we have 7 arrivals in the process. Okay, if this is a line, or maybe we are selling something at our shop, we are doing sales. Okay, yeah, let's say we are selling rice or so. Okay, so it means that by in 5 hours time, or whatever your time definition is, at time 5 we have 7 what arrival or 7 customers. Okay, so we want to find the probability that if at time 5 we have 7 customers, what is the probability that at time 2 there were what 3 customers? Okay, there were 3 customers for this process. All right, sure. So with this, let's look at the solution. Let's look at the solution. So you can first of all look at this as a binomial distribution. Yes, that's the first analogy of this solution. Okay, as a binomial distribution. Let's look at it clearly. I've drew this timeline for a purpose. So at time 5 we have 7 customers, and at time 2 we have 3 customers. What this means is that between time 2 and time 5 we had what 4 customers arriving, because if by time 2 we have 3 and by time 5 we are having 7, meaning between time 2 and time 5 something happened. We had 3 more, like 4 more customers joining the 3 initially, making it 7. So looking at it, our total time is going to be from what 0 to that of what 5. All right, and out of this from 0 to 2 is going to have a weight of what 2 over 5, because 0 to 2 has a weight of what 2. 2 minus 0 is 2, that's the length, and the length for the entire space is going to be 5 minus 0, which is 5. So we have 3 customers from what 2, like from time 0 to what to 2. So meaning the probability there is going to be 2 over 5. All right, for 3 customers. Excuse, I'm coming. Yes, sorry. So and between time 2 and time 5, that is with a space or a length of what 3, because 5 minus 2 will give us 3. So this the probability is going to be 3 over what over 5. All right, with 4 customers. So that is what the first solution is looking at. So it's binomial with a probability 2 over 5. Okay, so we're trying to say that our interest is 3 customers. So meaning it's going to be 7 combination what 3, because the binomial distribution is n combination what x. So x here is going to be what 3. So 3 customers, and the probability there is 2 over what 5. Let's look at it again. 2 over 5, because we have 2 minus 0 divided by what 5 minus 0. So that's going to be 2 over what over 5. All right, yes. So the complement is going to be what 3 over 5, and that place we have what 4 customers. So that makes us the total. So this is the when you simplify this, you're going to get 0.2903. Okay, let's look at the second alternative. So we can also see that, okay, we said that the Poisson distribution has independent increment. Once we have the independent increment, let's look at the 2. So we can see that from time 0 to that of time 2, and from time 0 to 5, they are overlapping, they intersect, they have something in common. Because when I look at time 0 to 2 or time 0 to 5, sorry, you can see that it has some of the 3 customers that already appears from time 0 to 2. So they overlap. So we have to create that kind of independence, because we say that the Poisson process has independent increment. But looking at it from time 0 to 2 and from time 2 to 5, you realize that they have independent, the time domains are non-overlapping. They don't depend on each other. So because of that, we need to create that independence. So as we all know from general probability, this is a conditional probability, so we are supposed to get the intersection. All right, Intersection is supposed to be that's n of 2 equal to 3, comma n of what 5 equal to 7. But relax, realize that n of 2 is already what? It's already 3. So if it's already 3, then we can say that make it a subject, because if you say n of 2 minus n of what? N of 5 minus n of 2, we're trying to say that between time 5 and time 2, there were 4 customers, which is very true. Okay, between time what? Time 2 and time 5, there were what? 4 customers. So that's what that means. N of 5 minus n of 2, that's just that. And there are 4 customers, so no confusion about that. So divided by what? The normal, what's the name? Condition event, that's n of 5 equal to 7. All right, so once the independent increments, you can see that we can find the probability separately and multiply them as such. Okay, that means that the intersection simply will be equal to what? Probability that n of 2 is equal to 3 times probability that n of 5 minus n of 2 is equal to 4. Remember, n of 5 minus n of 2 becomes another Poisson process. Okay, it's not only the addition that gives us another Poisson process, but the subtraction also gives. Okay, so this will give us a Poisson process with a time interval of 3. Okay, because 5 minus what 2 is 3. Okay, and the k is 4 over there. So let's try to see with lambda equal to what 2. This first probability gives us this, and the second one gives us that, right? So the numerator will be seen as what? Multiplying these two separate probabilities. Okay, yes, yes. Remember I said this one, the the n is the t is 2 over here, and the Poisson process, the mean is lambda t. Don't forget lambda t. So 2 times 2, that will give us a lambda of what? 4. And also here 5 minus 2 will give us 3. So 3 times what? 2 will give us 6. That is why we have the lambda to be what? 6 over here. Don't be confused, right? Great. Let's look at the denominator. Simply that probability also give us what? So 5 is the time. So 5 times 2, that is 10. So our lambda there is 10 to the power. So you can see it from here. Alright. So 10 to the power 7 on 7 factorial e to the power negative 10. So as we simplify, we get the same answer as 0.2903. Okay. Yeah. So let's see the next one. Suppose that trains arrive at a station according to a Poisson rate of what? 1 every 10 minutes. What is the probability that exactly 2 trains arrive in the next what? 10 minutes, or that exactly 1 train arrive between 10 and 40 minutes from now? So now we know that the rate is going to be at 1 customer every 10 minutes. So means our lambda is going to be 1. For every 10 minutes, lambda is going to be 1. So what's the probability of exactly 2 trains in the next 10 minutes? So that means that probability of exactly 2 trains in the next 10 minutes. Let's look at 10 minutes and then 40 minutes. Let's see if they overlap. So we have 10 minutes, that is from 0 to 10 minutes, and from 10 minutes to what? To 40. So you can see that this is a continuous interval, they do not overlap. All right, so because of that, there's independence between what? The first event and the second one. So let's look at the solution into detail. So we have exactly 2 trains in what? In this interval, that's from time 0 to 10. Let's make that one event A, and event B is going to be what? 1 train in what? From time 10 to what? Time 40. Okay, if you know your red analysis very well, you realize that these intervals are non-overlapping. This one is closed and this is open. It's open at the left and this is closed at the right. So these are the joint intervals of the homogeneous Poisson process and are independent, as you can see. So let's find the probability of A and find the probability of B as such. So probability of A is going to be this, and the probability of what? B is going to be, because between time 10 and time 40 will give us what? 30 minutes, and 30 minutes give us a lambda of 3. Remember, 1 per every what? 10 minutes, so that will be 3. Okay, so we get the probability as this. And recall from a general probability that, remember they said or in the question. Okay, they said or, see this, probability of exactly what? 2 trains in the next 10 minutes, or, so or means addition or union to be precise. So probability of A union B is equal to probability of A plus probability of B minus probability of what? A intersection B. But remember, because A and B are independent, that's why we are multiplying the two probabilities. And as we do this computation nicely, we're going to get approximately 0.30583 as our final answer. Alright, thank you. So let's look at the last one. Okay, sure. Let me look at this. So the time x to wait in line is an exponentially distributed random variable with mean 5 minutes. Calculate the probability that the total waiting time will be longer than 30 minutes from the what? The time the customer or the time someone arrived in line, given that the wait has already been 20 minutes. So this is probability that x is above 30, given that x is above what? 20. Okay, this is a very simple question using the memoryless property. All right, this is this, and we all know that the exponential distribution does not record the 20 that's already happened. It can only record the extra 10 that we've added to the 20, and that is going to be a probability that x is greater than what? Than 10. And as our mean is this, our lambda is going to be what? The inverse of that, and that would be 0.2. We plug in, we get 0.1353 as our final answer. Let's look at the last one. You are given the following information. The amount of time one spends in an insurance office is exponentially distributed with mean of 30 minutes. Okay? P1 is the probability that Benjamin will spend more than an hour of total time in the insurance office, given that he has already been in the office for 20 minutes. Okay? Given that he has already been in the office for 20 minutes. Okay, so at 1 hour, we want 1 hour giving 20 minutes. So 1 hour is going to be 60 minutes. So probability that x is greater than 60, given that x is greater than 20. So let's see that. We all know that would be probability that x is greater than 40. Yeah, but let's look at it first. So that is this first one. So probability that x is greater than 40. This one, as you can know, it does not recall the first 20, so it only recalls the 40 we added. So memoryless property, don't forget. We plug it in and we get 0.2636. Let's look at the next one. We said P2 is the probability that Fafa will spend more than an hour of total time in the insurance office, given that she has just arrived. Okay, yeah. So this is a very simple question. So given that she has just arrived, meaning we are just finding the probability that x is above 60 minutes. Okay, yes, and that also give us this, simple as that. All right, yes. So we want p1 minus p2. Remember, just calculate p1, what the difference, p1 minus p2. So as we do that, we are going to get 0.1283 as our final answer. Thank you so much, cherished students. It's been a lovely tutorial and I hope you enjoyed it. Thank you so much. And this is the end of our tutorial session and the end of our sum process. Okay, so in our next video we are going to look at Markov chain. So stay tuned. I'll be right back. Thank you.